This journal question comes from 6.3. In 6.3, we talked about similar triangles. We talked about that symbol, this squiggle, which means similar. And we talked about some really big, the very main concept of similar triangles, where there are always congruent angles and there are proportional sides. Okay, so that's something to remember all the time about similar figures, congruent angles and proportional sides. Now it says in this diagram, triangle ABC is similar to EDC, and it's our job to write the statement of proportionality, okay? It's probably best if we write the similarity statement first, which is triangle ABC is similar to triangle EDC. And when it says statement of proportionality, that's talking about the sides of the triangle. And because our sides are proportional, we're going to make a proportion, and that's why you see that proportionality there, the statement of proportionality. So it's really just three ratios being equal, and those ratios involve the sides. The picture's there, but I always think it's easiest to look at the name. So if I choose my first side off of my first triangle, it's AB. The side that corresponds to it on the second triangle is ED. And just for reference, because I started putting ABC on top, I have to keep putting ABC on top. And because I put EDC on the bottom, I have to keep putting EDC on the bottom. You can't flip one triangle to the next on these. All right, second set of sides is BC, and that needs to go with the second set over here, which is DC. And my final one, I need to choose the order. If I decided to jump backwards here for CA, then I need to make sure I do this one the same way, which is going to be CE. So this is one way to make my statement of proportionality. The three ratios can move back and forth. They don't have to be in this order. And if any one of your names you want to flip-flop, so like some of us may have put AC here, make sure it's also EC. So if one of your top is flipped, make sure the bottom is also flipped the same direction.